everyone. Welcome to our podcast number 23. This is Ehsani, and today we are back together with Josh Ahumada.
Hey,
Coming to you and talking about the repair of timber piles, which is something that we run into a lot, both piles as well as utility poles and other timber structures. So we thought Josh gets a lot of calls from contractors, and he talks to them about different problems that they have or solutions they're looking for in the field. So Josh, tell us what has been going on lately.
I've actually wanted to take this back to where we first entered the marine industry. I've been with you 18 years pretty much, and the marine, I can remember going back to Ports 2013 Seattle. I was out there and we're advertising our product, and timber, obviously, you think of piles. A lot of people think of timber because, you grow up, you go to a pier, it's more accessible to people that they see it. But, entering the industry at that time, I noticed that a lot of what the industry was then was, a lot of form work and pouring grout.
Mm-hmm.
And basically, we came into a market with a little different of a product, right? We came in with the idea that you're going to have this laminate and you're going to wrap it 2 times around and create a structural shell, no seams, right? That was the downfall of having shell jackets, is that you didn't get that. And so, that kind of started out as our benefit. But as we went on, we started to realize that this product has a lot of benefits for timber, not just putting it on a jacket with cementitious grout, but what our product can do for a team on site, for instance. So just to kind of give the viewers a little know-how on the product, this kind of gives us an example that you will see the timber pile, and our system pretty much consists of you building the shell on site. So that's something we realized right away. You're building this shell to size on site, and how you do that is with our spacers. So we got 2 here, and we got our 3-inch, and as you can see, they're holding some GFRP bars, which hold number 6 and number 4 GFRP bars. But no matter the size of the timber, you were always going to create that annulus. You would control that annulus. So the jacket might not be an exact number all the time, but the annulus would be. And as the engineers, that's what you're designing, correct?
Right.
You're designing that annulus, and that's what's going into the calculation. So one of the benefits we realized right off the bat was you go to a project that has number 12 or 12-inch piles or 15-inch piles, you're not prefabricating these to size. We have a warehouse of a couple hundred rolls back there right now, right? So you go to a project, and let's say we design with 2-inch spacers. Well, you just go off a 400-foot roll and you just start wrapping it, and you do your 4-inch overlap, and you can continue. We've definitely done timber pile 30, 40 feet. So, you could do anything from the splash zone repairs.
And really, Josh, as you know, especially with timber, because of the non-uniformity of the size of the timber and the variations, there have been jobs where we actually started the job that the engineers that had inspected the project, they put in their report that these were 12-inch diameter piles. And we got to the job site after several weeks or months even, then we realized that these piles that we are repairing are closer to like 14-inch, not 12-inch. But the good thing about this product is that you don't need to worry. You don't have to return any jackets, because we were just making the jacket on site. And
Well, I'm glad you brought that up, because I actually went out to New Orleans a couple months ago. We had sent product out there, and I went to go train the team out there to go perform the work. And during the training I was out there, they actually, one of the mornings, they went out to go do an inspection on site. Now we had sent out material for 8 foot in length of repair. What ended up happening was while I was there, they ended up determining that they needed 12 foot height of repair on 50 plus piles.
Yeah.
Well, I mean, imagine if you had these things pre-made. You're not going to go that much coverage, over in case, you're not right on the 8 foot. So all I had to do was call our warehouse to send another roll. And these guys never stopped or they didn't have to pause or anything. So that kind of shows the benefit of our product, that how it comes in on a roll. You're making it to size on site, so 2-inch, 3-inch annulus with grout. And then the benefits we've talked about before, our jacket, once it's installed, you have confinement. So the reason why you don't ever see hoop bars in our system is because the jacket is providing that, right?
Yeah.
So
the jacket basically is like if you put it in 2 wraps, which is our standard detail, says 2 wraps plus 8 inches. That 2-layer system gives you the equivalence of having a number 4 steel tie every roughly 3-inch along the height of the pile, which is far more than what usually you would require. So we eliminate the need for external ties. And that really helps a lot with, instead of handling a rebar cage, you just put the individual bars and the jacket becomes your confinement or hoop steel.
And another thing maybe to mention, I think we updated our website with the design example on the one-time wrap, right? So just for protection piles.
Yeah, if you can. So you can really, we have now 2 standard details. One is for most of the structural strengthening jobs where you would go 2 wraps and 8-inch overlap, or if you only want to just create a shell to protection and pour some grout or resin in it, you could go 1 wrap 360 degrees and then a 12-inch overlap, and we have tested these to make sure that 12-inch on a single wrap, it is long enough that when you subject the pile to hoop stresses, it will not fail at that overlap joint.
So we do that on some people who want to just put the grout for preservation, but keep the economics down. So that helps out with the contractors as well. And we definitely have had that. And then the last thing to mention too about our system, just to remind people, is we have a gel coat. So it has the UV protection that most systems do not have. So even on the protection style projects with the 1-inch, the one-time wrap, you're still getting that protection.
Yeah, the gel. Yes.
So, those are some of the benefits that we wanted to show with the traditional methods, let's say, right?
Yeah.
These were kind of our version of it. A little bit sleeker because usually the other ones had a larger annulus.
Yeah. So the traditional one that Josh refers to, that what we do is like what he's holding, that we would put usually like a 2 or maximum 2 or 3-inch annular space, put a few rebars. We usually use FRP rebars because these are in marine environments, so they don't corrode. And then we would fill the annular space with a cementitious grout, like typically an underwater grout.
And just so people know, we have our 50-pound bags. So we brought products here.
Yeah.
So I just wanted to make sure people know that we have it, we sell it, but we also have a grout spec.
Yeah. So this would be the 50-pound sack of cementitious grout, if you want.
No shrink underwater grout.
Yeah. Now we want to maybe show them the other.
Yeah, actually here. So what I've been seeing recently a lot, and this is kind of what we have going here, is our epoxy grout. This has been a big change. I have noticed recently people being more acceptance to actually paying a little bit additional cost to use an epoxy grout with a timber application. And there's a lot of reasons to do that just outside of our own jacket alone. Epoxy grout has some properties that would improve the system. You got some bond, you got some tensile strength to the epoxy, you got some the potential, the epoxy actually getting into the timber, absorbing into the timber and filling some of the voids. So the epoxy systems, epoxy grouts can do that. When you're doing an epoxy grout system, you're dealing with the bag of sand. gradated specifically, to get a larger yield out of the epoxy. So for instance, a 3-gallon kit, you see 150-pound bag, but you can use 3 of these bags to one kit, max yield. Typically not pumpable. People use 2 bags, get a smaller yield, but it is more flowable. Gets in all the nooks and crannies on a pile. So I have a little cured sample here that kind of shows an epoxy grout, and it's obviously like a solid piece of strong plastic. You would definitely fill
all the voids.
You would, fill all the voids, build an extreme barrier on this. But now let's talk about, using this product on a pile, right? Mm-hmm. If you have a timber project, it could be the same size or different size piles. It's still nice to be able to control the annulus. So we still have a 1-inch, we even have half-inch spacers that you can actually attach to the timber just like this, reduce the annulus, and same thing, apply our jacket around and have a strong shell, mm-hmm. and then you put that with epoxy grout. Now you really have a strong system, right?
And the whole thing really is that what we want to, epoxy grouts are, more expensive than cementitious grouts, obviously. So we want to minimize the volume of the grout. And this way, you have like, if, half-inch to 1 inch is really as small as you can go to make sure that it flows all around it. But if you can get it, and if you can get it half-inch, that would be great. If not, you can go to like a 1-inch spacer and get that ring of epoxy grout installed around your pile.
Now, one thing I did want to mention, for everybody out there is that a lot of customers do ask me, can you give me both pricings for the cementitious grout and the epoxy grout? And I'm going to tell you right now, reducing the annulus reduces the amount of PileMedic you need to use, the fill material. On average, I'm seeing about a 10 to 15% increase in cost on the overall material cost for the project when you use epoxy grout. It's more, but I wouldn't say it's substantially more, even on the overall footprint of your project once you consider your execution and all your other costs on the project. So to me, it is worth the benefit of going toward the epoxy grout. We believe PileMedic has the best system on the market to be able to encapsulate the epoxy grout. And then again, Mo, we can put reinforcement in this, right?
Right. Yeah. So you could, if you wanted, if you go with the, remember the annular space. Typically, when you use epoxy grout, you want to have a smaller annular space. So you may or may not have enough space to put a rebar in there. Perhaps maybe if you have a 1-inch annulus, you could put a half-inch or number 4 rebar. But definitely one other way is to use these carbon laminates that you can, these come in like we have them in 4-inch wide width, with any length that you want. And these can be put around, vertically positioned around the pile before you wrap them, and so these provide significant strength. And in cases where you have bending strength is a concern, then adding these elements, whether it is the carbon laminate like this one or a rebar, would add a lot more to that strength. And more importantly, really keep in mind that our PileMedic jackets, so you see these jackets, not only they have strength in the hoop direction, but they also have a lot of strength vertically. Now, normally, we conservatively ignore their contribution in the vertical direction if we are using a cementitious grout. So we just assume that, there's not enough load transfer if you're using cementitious grout. But definitely when you use an epoxy grout, now you have all of the contribution of this jacket to the bending strength of your pile as well, because, this is the strength of the jacket in the vertical direction gets transferred to the pile through that epoxy grout joint.
So would you say at 1-inch annulus with our system on most timber? I mean,
This would be plenty. This is plenty. So plenty. And really, even if you could get it to 3/4 inch or half inch, if you think that you can manage to get the epoxy grout to flow around it, that would.
Well, I think we do have a way to do that, which we're about to show. But one thing I actually wanted to also brush on too is people deal with getting the epoxy grout into the system. We sell our ports, which works for the cementitious grout. People still use these as well for epoxy grout. Now, some people will use pumps to pump in epoxy grout. A lot of these companies have a lot of experience doing that. There's ways to do it. You absolutely have to be very cautious on doing that. You have to have a good game plan on to avoid exotherm, to clean the equipment right away. But yes, a lot of the contractors out there have figured out good ways to do that and use other ways to enter the epoxy grout into the system. Tremie grouting is absolutely a way to do it. So, those are challenges, but the contractors we've seen out there that have been doing this, they have their ways that they do it, and they can do it very effectively. So I do want to bring that up because it is a question that we do get asked about a lot.
Yeah, just you really need to be planning, like Josh is saying, plan ahead of time, because if you're mixing it, for example, in your mixer and in your hose, you don't want to leave it in the, obviously, the stuff is going to solidify quickly. So you have to have a plan to get rid of all of your mixed products and then flush your system so nothing stays in it, and extend the life of your equipment that way.
Yeah. So now that we've talked about our system, about this building the jacket to size,
you want maybe show them that thing.
One of the benefits that our system has that nobody really can do is wrap the jacket on tightly. Now, this one was meant to look nice because it's carbon fiber, but you wrap it on tightly and you inject a neat epoxy in there. That's our 320 LV. The epoxy at room temperature has 600 centipoise, so it's good enough to flow in there. Not too thin where it's just going to leak everywhere, but it definitely gets into every hairline crack, every nook and cranny. Mo has another sample by him he could put up. But this system right here, we will tightly wrap, and we have a video we can show here in a second, but we will tightly wrap the laminate right on the timber. If you have checking, like you do here, you're going to get good flow. But a very common tool everybody has for timber is we just get a chainsaw, we score it helically, wrap it tightly, and we can gravity feed it. Or another way to do it is we'll get smaller HDPE tube, we'll insert it in, we'll create the cavities with the chainsaw, insert that in, wrap around it, and we'll either kind of Tremie method it out, or we'll just abandon the tubes in there. They are plastic, so it should be fine. But now we have this 320 LV, which has great properties, can go underwater as well.
Yeah.
Everything actually can go underwater, just so everybody's aware. But this one is kind of that sleek design, right? Doesn't leave a footprint. You paint this, people have a hard time finding it because it doesn't change the profile. So there's that need, right?
Yeah, and so this is really a cut section of a similar type of repair where we had repaired a piece of pile stub of it, and just by gravity feeding that resin in, and you see that the jacket is so tightly wrapped around this because we actually, like in this sample, we put 3 PVC tubing at roughly 120 degrees around here, and then when we feed the epoxy, the resin through it, it goes, and as you can see, the dark colors that you see here, this is actually the epoxy that has penetrated through and filled all those cracks which were not visible to us from the outside. So definitely this low viscosity resin finds all of the invisible voids and cracks, which is a plus and a challenge to also keep in mind, because sometimes these piles are so severely corroded or deteriorated from inside that it is hard to estimate how much resin they would absorb. So, as a contractors, most of you, the way we usually do this is just assume, for example, maybe you need a gallon for every 3 feet of pile or whatever. But then, then it is best to charge that as labor and materials, and just because it's hard to estimate the volume of missing the cavity inside of some of these piles.
Yeah. Now, at the same time, we could put reinforcement in this too, right?
Yeah, we could. Well, with
The
this,
same carbon?
with this one, if we want, again, because we are wrapping it so tightly, so the only product that you could use with this would be these carbon laminate strips. They would be put around here, and then you wrap your jacket and tightly, fill it. We've done some like utility pole repairs with this system, that where we use those carbon strips and then wrap either the fabric or the laminate around it to
One project I like to talk about was Montana DOT at one point had a job order contract utilizing our product on a lot of their county bridges that were timber. They're very old. And I believe they did over 40 of them. And the reason why I like to point this out is I actually was out there and I got to see the way that they executed it. They had a flatbed truck. They had the roll of product on the back of the truck. They actually had the 320 LV you see right here. It doesn't need the sand, but here just the product itself, the neat resin. They had this in drums on the back of their truck, and they were pumping it out as they needed it. So they would pull up to a bridge, just walk down there, take measurements, unroll it off the back of the truck, pump the resin out of the drum, and they were filling these things up and just going on to the next bridge. Yeah. I mean, to us, we take pride because what other system on the market can you really just go and do that to these piles that are somewhat submerged, right? Yeah. We do sell a wet layup system that people could kind of build this size, but you're not getting in the water with that, and this is encapsulating these timber piles. So
the only thing, another precaution is that, especially when, like, in some of these jobs where you're in a hurry to get a lot of them done in a day, you have to make sure that when you pour that low viscosity resin, pour enough to do, let's say, the bottom 5-6 inch of your annular space, and then give it some time for this resin to find its way through all the cracks and fill the cracks, and then create basically a seal at the bottom of your formwork. So if you just continue pumping it without allowing that to set, you're going to waste a lot of resin getting into the soil, and you obviously don't want to waste your resin that way. So it's better if you have several of these piles to do, maybe in each of them put a little bit at the bottom, wait an hour or two for the resin to solidify, and then you can fill the rest of them all the way.
Well, kind of to expand on that, a normal plug system, sometimes, like, let's say we're a splash zone, they'll do a foam maybe, and they'll put in product and solidify it, maybe 6 inches, a foot, and they'll call that the plug. So what Mo's describing is essentially the plug in the same sense. You're letting this epoxy solidify a little, so then it solidifies the leaks. But instead of a foam, in certain circumstances, we do utilize a hydroactive urethane that we saturate in a piece of Oakum rope, and we'll place that at the bottom, and it will expand underwater. So we do have methods to plug the bottom of these so it just doesn't spill out on you. And like he said, then you would put an initial amount, and then you go up, the rest of it. But I mean, even if we wanted to backtrack a little, even on the cementitious grout designs mode we do suggest, even on those ones, epoxy grout plugs, correct?
Yeah. So in all of our really grouts, because one of the ways we try to protect the pile is that you want to keep moisture and oxygen away from the pile to stop the corrosion process. So obviously, if you fill it with an epoxy grout, the epoxy grout itself is impervious and you don't need to worry about it. But in the jobs where we want to keep the cost lower, let's say, and we are filling the bulk of the annular space with a cementitious grout, then even in those jobs, we seal the bottom and top of that cementitious grout with a layer of epoxy grout. So you have an impervious epoxy grout at the bottom, let's say, for like maybe 3 inches or so. You have the bulk of the annular space filled with cementitious grout, which is lower cost. And then the top of the cementitious grout, you have another 2 or 3 layers of epoxy grout. And so that whole cavity then is sealed, and no moisture can get inside of that or to get to your pile.
So pretty much our designs going out from here, we've been putting those in our designs when we use cementitious grout, because we're stamping it. We like to have that assurance down there. So that kind of really sums up a lot of what we wanted to talk about timber. Mo has a couple things that could kind of show, and I don't know if we would be able to. Here's that time lapse.
This one is a time lapse photography that Josh was doing for a job for Caltrans a year or so ago. So it's really short. It already.
Maybe show it one more time.
It's So maybe I can even if I pause it or something. So basically, the laminates. You see that they have put the first 4-foot tall jacket at this stage around it, and it looks like they're filling it already. To
do that plug that you talked about, yes.
So there you see they're putting that, and then they go to the next 4-foot jacket. These go 4 foot, 4 foot. Here it goes. Then they put the next one, and now you've covered 8-foot tall height of the pile, and it gets filled with resin, that low viscosity resin, and then at the end, when it is all done, you can of course paint these and make them in this case paint them brown like the color of a timber, so it looks really nice at when they're done. I remember many years ago we did a utility pole for our electrical company here that it was a severely corroded timber pile, and with this system that I was showing you, we actually made that old pole, utility pole, as strong as a new steel pole that they required for that location. So without taking it out of service, we did the strengthening, made it as strong as a new steel pole. And then after we painted that, you really have a hard time distinguishing that pole as you're driving on the road.
You did the same with that project.
Yeah.
You told me you couldn't find it.
I was going there to take some pictures of it after 10 years in service, and I literally could not find it until I had to put the address of the site and go find where the pole was. So it's that's another thing. I guess we really, I don't know. We have a PowerPoint that it didn't. Let me see if we add this.
Just a couple photos.
This is basically all of our systems. Again, you see the laminates. They come in these 4 feet wide rolls that are several hundred feet long, 400 feet or so long, and that's the way they are. The spacers, the FRP rebar, the bottom seals that we have been talking about, and the grout port, and and then we of course have the carbon strips for some of those jobs, as well as in some cases we do use the fabric. In utility poles, for example, when they are these timber poles, it might be easier to use a fabric to wrap it tightly right on top of it without any annular space, and the fabric, because it's flexible, it almost takes the shape of the pole itself. So this table that I put in here kind of summarizes some of the, let me just go back to the table here. Yeah, so these different ways of repairing a pile, we've just summarized them in here. If you go with the low viscosity resin, you have to use I call it, minimal, as little as you can, or even wrap it tightly around the pile. That would be good. With epoxy grouts, anywhere from 1/2 inch to 1.5 inch is more than, is enough. And then with cementitious grout, typically, from 1 to 3 inches is what we see. Now, you could use all of these with no reinforcement, or you could use, in terms of, you could use the carbon strips. The carbon strips, they should be used in cases where you use an epoxy material as the fill. So it could be either the low viscosity resin, just pure resin, or an epoxy grout. In those cases, this would be good. Otherwise, this does not stick or bond well to cementitious grout. So it would be no benefit to add that if you have a cementitious grout. But when it comes to FRP bars, then usually if we use low viscosity resin, we don't have a big, not that, it would stick to it, but we don't have a big enough of a space to put the rebar in there. But if you're using the epoxy grout or cementitious grout, with those cases, we definitely can use the rebar as well for those applications. And for this one is really for more like for timber poles. Poles typically are obviously above, they are not in water, so they are above ground. And in those cases, you can, wrap them with that a resin saturated fabric that has, creates the shell around it in a flexible form. You wrap it and then you have the shell. Before wrapping the shell, you could optionally add some of these carbon strips, and then at that stage you would inject it with resin, and that's the way. So this, maybe this will end it with this one, but really this slide summarizes the benefits of it. From a construction and cost savings, the nice thing about our system is that you can exactly calculate the volume of grout that you need based on the annular space, which comes from the size of these spaces. So whether you use a 1 inch, 2 inch, 3 inch spacer, you know exactly how much grout you have. There won't be any cost overruns for that, and that's really a main advantage. As well as, of course, the feature that you wrap the jacket in the field and make it in the field, you don't, you won't end up with an oversized jacket arriving to the job site and say, it's here, let's use it, and then fill it with a lot of extra resin or epoxy. Maybe since we're getting close to the end of this, I have one other product that we have. This, product is called Formatube, and we developed this several years ago because, on some of these jobs, the engineers, the contractors, they didn't really want this strength of the PileMedic jacket that it provides. So these, what they are, in fact, let me show you, as you see here. Let me stop sharing this. All right, so this product, that, as you see, these come in strips that are about 6.5 inch wide, and they have these on the back side of them. They have these protruding T-profile. So you simply snap these together like Legos without any epoxy or any bolt. You just slide these together, and each one of these that you add, you increase the diameter of your tube by 2 inches. So if you want to make for example, 12-inch diameter tube, you need 6 of these. 6 of them will give you a 12-inch tube. And then you put this around your pile, and when you pour your grout in there, again, these T-profiles grip the grout, and they stay in place. We've done some jobs with this. A lot of homeowners primarily buy these and order them and do it themselves because it's so easy to do. You also, as far as so the diameter is easily controlled by how many of these you include, but also in terms of the length, you can stagger the joints, and by putting the next one a little bit off of it, you can extend the height of these from short ones. You can make a jacket of any length that you need, and that's our Formatube product. But I think we're almost done with our time. So it really.
Well, one thing, just to remind everyone, through these products, we don't really have lead time. You call us, you have a project ready to go. We have product here to send. Cementitious grout, things like that, yeah, you might get a little bit, not too long. Usually doesn't exceed over 2 weeks to actually get stuff out the door. But we have tons of rolls of PileMedic in the back. So just want to reiterate the benefit of this stuff is readily available. We know summer's approaching. So, if you have timber piles, feel free to reach out.
Yeah. All right. Well, thank you again, everyone, for your attention. We look forward to seeing you in our future podcasts.